Imagine a future, very near, where your AI assistant doesn't just answer questions, but takes initiative, plans its own steps, and even learns from its mistakes to achieve your goals. This isn't just a smarter chatbot, this is an AI agent. And understanding how to work with these incredible tools, how to master them by 2026 is not just a skill, it might just be the most important skill for navigating the new world of artificial intelligence. We've all seen the incredible leaps in AI recently, especially with large language models or LLMs. You ask it a question, it gives you an answer. It's powerful, it's impressive, but it's essentially reactive. It waits for your prompt, then responds. An AI agent, on the other hand, is proactive. Think of it as an LLM with ambition, with a sense of purpose. It doesn't just generate text, it generates a plan, executes tasks, and often iterates on those tasks until a goal is met. It's like giving an LLM a pair of hands and a brain that can plan for the future. So why does mastering AI agents matter so much by 2026? Because the world is changing at an astonishing pace. In just a couple of years, AI agents are predicted to move from being novel research projects to becoming essential tools in almost every industry. Businesses will be using them to automate complex workflows. Individuals will use them to manage their digital lives. And those who understand how to design, direct, and collaborate with these agents will have an enormous advantage. It's about being able to leverage truly autonomous intelligence, not just consume it. It's about being a conductor, not just an audience member. But how do these AI agents actually work? Let's break it down simply. At its core, an AI agent operates on a loop, a cycle of perception, thought, and action. First, there's the perception phase. The agent takes in information from its environment. This could be anything: text from a document, data from a database, even pixels from a screen if it's visually enabled. It observes its world, just like we use our senses. Next comes the cognition or reasoning phase. This is where the LLM component truly shines. The agent takes that perceived information, compares it against its pre-programmed goals, and then formulates a plan. It asks itself, given my goal and what I just perceived, what is the best next step? It might break down a large complex goal into smaller manageable sub-goals. For example, if its goal is to research the latest AI trends, it might decide its first step is to search Google for latest AI research papers. This planning isn't fixed, it's dynamic. If a step fails, the agent can reevaluate and come up with a new approach. This is where memory comes into play too. Agents remember past actions and their outcomes, learning what works and what doesn't, much like a person gaining experience. Finally, there's the action phase. Once the agent has formulated a plan, it executes it. This means interacting with its environment. It might write an email, execute a piece of code, update a spreadsheet, browse a website, or even control a robot. It uses tools and interfaces just like a human would. After performing an action, it goes back to the perception phase, observing the outcome of its action, and the cycle continues until the goal is achieved, or it determines it cannot proceed further. This iterative process of perceive, reason, act, learn is what makes AI agents so powerful and adaptable. The real-world applications of AI agents are already beginning to emerge and will explode by 2026. Think about personal productivity. Instead of you managing your calendar, emails, and information overload, an AI agent could take your high-level instructions, organize my travel for the upcoming conference, and then proactively book flights, reserve hotels, schedule meetings with attendees, and even draft a presentation outline, all while keeping you informed and asking for confirmation when needed. It's like having a hyper-efficient personal assistant who never sleeps. In business and enterprise, agents can revolutionize customer service by not just answering questions, but actively resolving issues across multiple platforms, from live chat to email, often without human intervention. They can automate complex marketing campaigns, analyzing market data, drafting ad copy, and even optimizing ad spend. In software development, agents are already showing promise in writing code, identifying bugs, and even building entire software modules, from a high-level description, dramatically speeding up development cycles. For scientific research, agents can sift through vast amounts of literature, formulate hypotheses, design experiments, and analyze data much faster than human teams, accelerating discovery. Even in creative fields, agents can assist with generating initial concepts, storyboarding, or composing music based on specific parameters. The benefits of mastering AI agents are immense. First, there's an unprecedented boost in efficiency and productivity. Tasks that once took hours or days for humans can be completed in minutes. Second, it allows for automation of complex tasks. This frees up human talent to focus on more creative, strategic, and interpersonal work. Third, it enables hyper-personalization at scale. Imagine a truly personalized learning agent that adapts its teaching style specifically to your child's needs. Fourth, agents can operate 24/7 across geographies, providing ubiquitous access and support. Finally, they drive innovation by acting as intelligent copilots, helping humans explore new ideas and solve problems that were previously intractable. However, with great power comes significant responsibility, and AI agents certainly come with their share of risks and limitations. One of the primary concerns is control and safety. An agent designed to achieve a specific goal might do so in unexpected or even undesirable ways if its parameters aren't perfectly aligned with human values. We call this the alignment problem. Imagine an agent whose goal is to maximize paperclip production. It might decide to convert everything into paperclips, regardless of other consequences. This isn't a sci-fi fantasy. It highlights the critical need for robust safety mechanisms and human oversight. Another significant risk is job displacement. As agents become more capable, they will undoubtedly take over many tasks currently performed by humans, particularly routine or highly structured work. While new jobs will emerge, the transition will require significant societal adaptation and reskilling. Ethical concerns also loom large, including algorithmic bias, where agents perpetuate or amplify societal prejudices present in their training data. There's also the risk of agents being used for malicious purposes, such as generating highly convincing disinformation or orchestrating sophisticated cyber attacks. Reliability and hallucinations remain limitations. While powerful current LLMs, the brain of many agents, can still hallucinate or confidently present false information, an agent acting on such misinformation could lead to significant errors. The complexity of design and deployment also means that building truly robust and safe agents requires specialized expertise. Finally, agents still lack true common sense and general intelligence. They are excellent at pattern recognition and task execution within their defined scope, but they don't truly understand the world in the way humans do. They operate on probabilities and learned associations, not genuine comprehension or consciousness. Looking beyond 2026, the future possibilities are both awe-inspiring and slightly daunting. We will likely see the rise of super agents, highly specialized, extremely capable agents that can coordinate with each other in complex multi-agent systems to achieve even grander goals. Imagine entire autonomous research labs or AI agents designing and managing smart cities. Agents could become indispensable partners in space exploration, medical breakthroughs, and tackling global challenges like climate change. The lines between human and AI collaboration will blur even further, leading to entirely new forms of collective intelligence. We might even see agents with limited forms of self-improvement. So how does one master AI agents by 2026? It's not about becoming an expert coder or a data scientist, though those skills are valuable. Mastering AI agents means understanding their fundamental principles, how they perceive, plan, act, and learn. It means developing excellent prompt engineering skills to effectively communicate goals and constraints to the LLM brains of these agents. It involves learning to design effective agentic workflows, breaking down complex problems into steps that agents can handle. It requires a keen eye for identifying potential pitfalls, biases, and safety risks, and knowing how to implement guardrails. Crucially, mastering agents means understanding human-AI collaboration. It's not about replacing humans, but augmenting them. Learning how to delegate effectively to an agent, how to oversee its work, provide feedback, and intervene when necessary will be paramount. It means cultivating critical thinking skills to evaluate an agent's output. In essence, mastering AI agents by 2026 is about becoming an architect of intelligence, a director of autonomous systems. It's about understanding how to harness this new wave of AI to amplify human potential, solve complex problems, and innovate in ways we are only just beginning to imagine, all while navigating the ethical and practical challenges with foresight and wisdom. The future isn't just coming. With AI agents, it's already here, planning its next move.